Alright, in this video we're going to look at an Atwood machine, or one of these systems of two objects that are tied together or moving together. And this time one of the objects is going to be an incline and it's going to have a force of friction. So we're going to have a lot of little forces going on here. You'll also note in this system that we don't know the mass of those two objects, but we're going to see that it works out that since the force of gravity is proportional to the mass and acceleration is inversely proportional to the mass, the actual mass of these objects isn't really going to matter. We're going to be able to ignore it. So again, we're going to find the acceleration of this system by treating it as one big object, and then we'll look at the individual objects in the system to find the tension in the wire. I guess with the tension in the wire we won't know what it is. We'll only be able to find it in comparison to m. So let's start by looking at that object on that incline. So here's the incline, mass, the force of gravity pointing straight down. There'll be a component of gravity that's going directly into the incline, or the perpendicular component, and a parallel component. And if this is 30 degrees, then if this is 30 degrees, then that is 30 degrees. A normal force and a force of friction. I'm going to put the force of friction going down the incline. Since this object is hanging and it's more massive, what I'm going to understand is that it's going to be strong enough to pull this other object up the incline, and so the force of friction is going to be fighting against that or pulling it back down. This guy works out to 9.8 m cos 30. Sorry, force of gravity is equal to 9.8 m. So this one is 9.8 m cos 30. This one's going to be 9.8 m sine 30. My normal force is going to be equal to this force of gravity perpendicular. So it's going to be equal to, I'll just evaluate that, 9.8 cos 30, 8.5 m. And as soon as I have the normal force, I can find my force of friction. And I get 2.55 m. Finally, 9.8 m sine 30 is going to work out to 4.9 m. Now let's focus. So that gets me all the forces acting on my little m object that's on the incline. Now let's look at this 2m hanging object. And the only external force, there's a force of tension up here too, right? And so we have a force of tension and the force of gravity. The force of gravity is going to be equal to 9.8 times the mass. I'll use a capital M just to be clear. So that's going to make it, in this case, 9.8 times 2 little m. And so this is equal to 19.6 m. Again, I'm not paying too careful attention to my negatives or positives for direction, because what I'm going to do now is I'm going to treat the object as a whole. If this is m and this is 2m, then the whole thing would weigh 3m. And what I can imagine then is that the 2m hanging weight is pulling it in one direction, and the force of friction and the parallel component of this force of gravity are working the other direction to slow it down. So I've got 19.6 m pulling it this way, and I've got 2.55 m from the force of friction and 4.9 m from the force of gravity that's parallel to the plane, pulling it back. I'm going to call this direction positive, so that makes both of these guys negative. And now I can find my net force. That's going to be equal to 19.6 m plus negative 4.9 m plus negative 2.55 m. That's what it is. Okay. So 19.6 minus 4.9 minus 2.55 works out to be 12.15 m. And now I can use F net equals MA. I'll use a capital here just to make sure that I don't confuse it with the little a. And that's equal to 12.15 m. The total mass of the system is 3m. And I have the acceleration. M cannot equal 0, so I can cancel mass on either side. And the acceleration of my system is going to work out to 4.05 meters per second squared. Now with that, I can find an expression for the force of tension in terms of mass, but since I don't know the mass of the object, I can't get an absolute value for that. To do that, I'm going to focus on the hanging 2 kilogram object, or 2m object. If it's hanging, it's the bigger object, so it's pulling the system to the right, and as a result, it's falling. So that's the right magnitude for the acceleration, but the acceleration on that object is going to be negative 4.05 meters per second squared. And so the net force is going to be negative 4.05 m. With that in hand, I can recognize that the forces that are leading to that net force are the force of gravity and the force of tension. The force of gravity is equal to negative 9.8 m, and the force of tension is what I'm looking for. Net force is the sum of the forces. So negative 4.05 m is going to be equal to my force of gravity, negative 9.8 m, plus my force of tension. And moving the 9.8 m over to the other side, then I get a tensile force of 5.75 m. I can't go any further than that. I don't know the absolute value of it, but that is an expression of it in terms of the masses used in the actual problem. I've screwed something up here. The mass of this is not, hold on, I gotta be careful here because I've messed this up. The mass of this, so when I got the net force here, I just used m. I just said it would be 4.05 m, but the mass of this system is 2m. So when I found this, this should have been negative 8.1 m, because I forgot to take into account the fact that the actual mass of this object is 2.1 m. That means that this should have been 8.1 m negative. And one more time, actually, my force of tension actually should have been 1.7 m. So sorry about the mistake there, because I forgot that the mass here is 2m, not just m, that when I used F net equals ma, I should have put 2m in here for the mass, and then as a result I should have gotten 8.1, and then when I did my sum of my forces it would have worked out to 1.7 m instead. So there's that correction. So do the incline problem, find all of the values. Force of gravity perpendicular leads to a normal force, leads to a force of friction, and force G parallel. Parallel and force of friction are both unbalanced, the other two balance each other out. Find the force of gravity, treat the system as a whole, and come up with your net force in terms of m, and then as a result your acceleration. Using the acceleration, determine the net force, and as a result you can determine an expression for the force of tension. Careful if you have used a variable like m to represent the mass of an object and then you have something like 2m, when you go to substitute into F net equals ma, it's very easy to mix up the mass that you've declared as mass m and the total mass of the object. The way I avoided that here was I used a capital M in that equation, so I remembered to substitute my 3m. I didn't use a capital M here, and it was easy to make a mistake. So just be careful with that.